Hi, I'm Larry, WA7ZBO. A while back, I spoke with Cale on Ham Radio 360, and we discussed transmitter hunting as it relates to amateur radio, and I promised some follow-up video to show some of the equipment we use, and this is it. Enjoy. This is the most popular antenna being used in the field right now, and it's quite simple. You can actually build it for about $10. It's a 3/4 inch Schedule 70 PVC, some tie wraps, which I found really easy to put on with a tie wrap plier set that makes them really tight, or you can use hose clamps, whatever you'd like to come up with, and $3.50 measuring tape at Harbor Freight will build you about 5 of them, and then a T-connector and a couple cross joint connectors from the PVC department at Home Depot, and you're in business. So let's see how this thing works. Using a 5-inch piece of wire as an antenna matching device brings the SWR down perfectly for 2 meters. As we sweep the SWR with this antenna from 144 to 148, we find that it's coming down very well. And this one is looking like it's bottoming out at 147.38. But again, that's a very good pattern for the whole 2-meter band. Here's one of the reasons that a lot of the teams in the United States that are transmitter hunting uses measuring tape antennas, even though they can really afford very good antennas, because when you go crashing through the brush, well, let's go crash through the brush here. It doesn't care. It comes right back where it was, as long as you're not falling apart like mine here. So that's a great advantage to PVC antennas. Okay, the first direction finding device we're using is called an offset attenuator. Everything inside your radio is tuned to try and pick that signal up. So what we're going to do, we're going to move the signal up 4 megahertz, and then we can control what comes into your radio. Your radio is looking for a 149.55 signal, but we're actually down on 145.99, so we can control it and what goes into it with what this device is called an offset attenuator. So let's turn it on and we'll track our beacon. What we've done, we put the transmitter out there in a yellow Homer bucket, and it's beeping away, and that way you can kind of see how directional it is. So back to the unit and be right back, and we'll get it going. Turn on our attenuator, and as we turn it, the knob, it actually controls that signal and gets weaker and weaker. So we're able to walk right up on the pattern. Okay, we'll start off with no signal coming in. Again, we're looking right at the target. You notice there's nothing. But let's go down. There it is. Okay, we've got the general location. We'll start in towards it. Starting to get a little stronger. We'll back this down. There we go. And finally, when we're right on top of it, we can take it down even more. And that's how a offset attenuator works. This device is called a VK3YNG Sniffer 4. They're made in Australia. It's just for tracking transmitters, either in the CAP aviation area 121.5 or in the amateur radio 2-meter band. It's quite a bit more isolated, insulated, so it's not going to be getting signals in except through the antenna. And it has the added feature of, instead of a field strength meter or an S meter, it actually turns it into audio. So you can listen on your stereo headphones, the original signal on one side and the or the S meter audio on the other. So let's turn it on and we'll see what we got here. Okay, we got the sniffer on the measuring tape antenna, and give you a little volume. This also has automatic attenuation. So what happens as we close in on the target, the tones will get higher and higher and higher, and then it'll switch over and give me 10 more dB attenuation, and then they'll start up again, and then they'll keep doing that until we're right on the target, and I'll call out the attenuation. So let's go to the frequency. We already know it's 144, so we'll dot frequency 5550, and there we are. And it's picking it up, and we're already into 50 dB attenuation. We know that the target is out there in the Homer bucket. There we go. We're off and running. Thank you, jet airplane. Okay, we're coming up. Okay, we just hit 60 dB attenuation. Okay, we're into 70 dB attenuation. If I didn't know better, I think it was right in front of us. Do a little polarity switch. Must be laying down because it's horizontal. And there it is. Amazing. This is a commercially made antenna by Arrow Antenna Company. It's a 3-element Yagi, and it works very, very good. And if you're looking for something on a commercial basis, a little bit tougher, this is your antenna. Another antenna you may run into is called a switching antenna. And they're either homemade or commercially built, like this one from Radio Engineering. And it's used quite a bit. It was one of the earlier antennas before we got into specialty Yagis. And it works with the signal time arrival at the antennas. So if one's picking up the signal a little before the other one, it tells you to turn the antenna, and you null it out, so they're both picking up the signal at the same time, and supposedly you're going in that direction. So if you find these switcher antennas, they work very well, but they are prone to multipath, so you have to really keep walking and taking readings. Here's some of the other toys we have out here. This is called a Fox Finder. It's put together by a radio club out in, where was it? Looks like Massachusetts. It's kind of a fundraiser. Now this is unique because you don't dial any frequency in. As you get close and start, maybe your antenna's overwhelmed or something, you pull this out, and there's attenuation on the side for minimum and maximum sensitivity. This covers the entire VHF spectrum, so whatever's happening in the VHF spectrum that's close to 2 meters, you're going to be picking it up without dialing in a frequency. This is a Faraday loop. This is made by Arrow Antenna. They make UHF and VHF, and it works on pretty much the same principle as big antennas you see on aircraft, or if you see the Nazis driving around in trucks with loop antennas going back and forth. What happens is when both sides pick up the signal at the same strength, it nulls out. So instead of going for a peak on this, you take it and you look for the null, and that's the direction you want to go. This is another type of attenuator. This is a passive attenuator, and you can see it's got 35 dB, 35 dB, 10 or 20 and 10, And again, this will cut the signal down between your radio and your antenna, but there will be coming a time when you get so close that even this much attenuation won't be effective. And that's where the offset attenuator really shines. This one is made by National RF, same people that made that switcher antenna we just saw. Now a lot of guys, when they get in close, they use a field strength meter. This particular unit I bought from Lafayette on Radio Row in New York, which was a wonderful, wonderful place until they tore it all down and put the trade centers up. So that tells you how long ago I bought this. There are other RF meters out there, field strength meter. This one's put up by MFJ. It's a 802B, and the problem is with stronger transmitters it works pretty good, but with the low power that we're using on the units now, you can see you really have to get close to it before it really shines. Well, that's it. I appreciate you watching. Goodbye from wonderful hot Utah. Humidity's nothing, but the temperature is everything. 73 from WA7ZBO.